Hello students, so here we are with the lecture 2 of aldehyde, ketones and carboxylic acids. In this we will be studying about preparation of aldehydes and ketones and physical properties of aldehydes and ketones. So general method of preparation of aldehydes and ketones. First one is by oxidation of alcohols. When primary alcohols are oxidized, aldehyde is formed. When secondary alcohols are oxidized, ketones are formed. But then if this oxidation is done in the presence of mild oxidizing agents. So when primary alcohol is oxidized in the presence of pyridinium chlorochromate, that is PCC, you get aldehyde. When secondary alcohol is oxidized in the presence of chromic oxide, you get ketone. Okay, for example, ethyl alcohol, which is a primary alcohol, on oxidation with PCC gives you acetaldehyde having same number of carbon atoms, and when isopropyl alcohol, the secondary alcohol, is oxidized in the presence of chromium oxide, you get acetone, which is a ketone, right? Now let's see the next method. Next method is by dehydrogenation of alcohols. Dehydrogenation is also called oxidation, but then the conditions are different. Primary alcohol, when reacted with copper in the presence of copper at 573 Kelvin, gives you aldehyde, and secondary alcohol when heated with copper at 573 Kelvin gives you ketone. Okay, so this is dehydrogenation of alcohol. And ethyl alcohol when reaction with copper at 573 Kelvin gives you acetaldehyde, and isopropyl alcohol on reaction with copper 573 Kelvin gives you acetone. So what is the difference between ethyl alcohol and acetaldehyde? The difference is of one H2. That means hydrogen is removed in this reaction, and therefore the reaction is called dehydrogenation. Okay, which takes place in the presence of copper when heated with copper at 573 Kelvin. Aldehydes or ketones are formed depending on the parent alcohol is primary or secondary. Clear? Okay. So when alkenes are ozonalized, reacted with ozone in the presence of solvent, ozonide is formed. Then when this is reacted with zinc and water, it gives you aldehyde or ketones. The bond breaks like this. One oxygen is given out. This oxygen combines with water to form H2O2, which reacts with zinc to form zinc oxide plus water. Okay. So when ethene is reacted with ozone, you get ethylene ozonide. Then the bond cleaves from here and you get two molecules of formaldehyde when reacted with zinc and water. And zinc oxide is formed as a side product. Okay. So if this alkene is taking 2-methyl butane, then what happens on your ozonolysis? Ozone molecules gets added between the double bond and the bond cleaves and you get acetone plus acetaldehyde. So from the products of obtained in the ozonolysis, you can predict the alkene. Okay, clear? Okay. Bihydration of alkynes. So alkyne when reacted with water in presence of sulfuric acid, 40% sulfuric acid and 1% mercuric sulfate, it gives you aldehyde or ketone. So ethine when reacted with water, H and OH gets added here. So you get CH2 double bond CHOH, that is vinyl alcohol. Then there is a keto-enol tautomerism, that H that is there with the carbonyl oxygen, carbonyl carbon gets shifted to this side and you get CH3CHO. Okay. So this is keto-enol tautomerism. So you get acetaldehyde as a product. Then if prop-1 ion is reacted with mercurous sulfate, sulfuric acid hydrated in the presence of sulfuric acid and mercurous sulfate, then you get first the water gets added here. So OH is added with the carbon containing CH3 and H is added on the other side. So you get CH3, CHOH, COH, CH2. Oh, double bond CH2. So then there's a shift in the hydrogen from this carbonyl oxygen to here and you get CH3, CO, CH3. So acetone is formed. So prop-1 in 2 all is formed and there is a keto-enol tautomerism and the ketone is obtained. Clear? So prop-1 ion gets converted to acetone. Clear? Then other method of preparation of aldehydes and ketones are Rosenmann's reduction. Rosenmund's reaction, what happens, children? Acyl chloride gets converted to aldehyde. So acyl chloride is reacted with hydrogen. Hydrogen gas is passed in acyl chloride. In the presence of palladium and barium sulfate, you get aldehyde plus HCl. Clear? So if the acetyl chloride is taken, then you get, when you react pass hydrogen gas in the presence of palladium and barium sulfate, you get acetaldehyde plus HCl. Clear? Then preparation of aliphatic and aromatic ketones from acid chloride. So what happens when acid and aliphatic and aromatic ketones have to be obtained from acid chloride? Then first, Grignard reagent is reacted with cadmium chloride. Alkyl magnesium halide is reacted with cadmium chloride. You get dialkyl cadmium plus magnesium chloride. Then this acyl chloride is treated with dialkyl cadmium and you get ketone plus CdCl2. So 2R-COCl plus R2CD. So R-COR is formed and CD2Cl2 is a side product. That's how from acid chloride the aldehyde and ketone is obtained. Clear? Okay. So let's see one more example. Ethanol chloride when reacted with dimethyl cadmium, it gives you propanone. Okay. Benzoyl chloride when reacted with dimethyl cadmium, it gives you acetophenone. So benzoyl chloride can be converted to acetophenone using dimethyl cadmium. Yeah. Then Stephen's reduction. So Stephen reduction is also another method to prepare aldehyde. So when alkyl cyanide is reacted with tin chloride and HCl, nascent hydrogen is obtained. This hydrogen gets added on the triple bond and you get imine hydrochloride. This on hydrolysis, this imine hydrochloride RHC double bond NHCl on hydrolysis gives you aldehyde and NH4Cl is obtained as a side product. So that's how you obtain aldehyde from alkane nitrile, right? Then if you have ethane nitrile, so on reduction with tin chloride and HCl, you get ethanamine hydrochloride, CH3CH, double bond NH, HCl. Then this on hydrolysis gives you CH3CHO plus NH4Cl. Clear? Then benzonitrile on reduction with tin chloride and HCl gives you benzamine hydrochloride, which on hydrolysis gives you benzaldehyde plus NH4Cl. So that's how from the nitriles aldehyde is obtained by reduction using Stephen's reduction method using tin chloride and HCl, which provide nascent hydrogen. Then unsaturated nitrile are reduced using dibal-H, that is diisobutyl aluminum hydride, to imine, followed by acid hydrolysis to give aldehyde. So here you see pent 3-ene nitrile, the unsaturated nitrile, on reaction with dibal H, that means diisobutyl aluminum hydride, followed by hydrolysis. This gives you pent 3-enal. So here CH3, CH double bond CH, CH2 and this is CHO. Okay. So CN gets converted to CHO. So first imine is formed here as here and then followed by acid hydrolysis gives you aldehyde. Clear? So unsaturated nitriles are reduced using which reagent? Dibal-H, diisobutyl aluminum hydride. Okay. Then preparation of ketone from nitrile and Grignard reagent. So ethane nitrile when reacted with methyl magnesium chloride in the presence of dry ether gives you CH3, C, CH3. So this CH3 adds here on carbon, double bond N, MgCl, okay, gives you on hydrolysis, this gives you CH3, C double bond O, CH3 plus ammonia plus MgCl, MgClOH, okay. Understood? So CH3 is a negative, it goes on the positive part, that is adds on carbon. So CH3, CH3 bond is formed and triple bond gets dissolved to double bond and you get a valency here. So N is there and MgCl gets added here. Okay. So this intermediate form and this on hydrolysis gives you CH3, CH3, double bond O and N gets converted to NH3 and Mg gets converted to MgClOH. Right? So that's how ketone is obtained from ethanitrile. Then benzonitrile, which ketone is obtained? Acetone is obtained from ethanitrile. Then now benzonitrile, when it's reacted with phenyl magnesium bromide, Grignard reagent, similar reaction takes place. C6H5C, C6H5 gets added on carbon, double bond and MgBr. Okay. This on hydrolysis gives you benzophenone C6H5, C6H5 double bond O plus NH3 plus MgOH Br. Right. So that's how ketone is obtained from the nitrile. Right. Then from aromatic hydrocarbon, how do you prepare aldehyde? So aromatic hydrocarbon, the aldehyde prepared will be benzaldehyde. So first is the Itard reaction. So toluene, when reacted with chromyl chloride in the presence of CS2, it gives a chromium complex. Okay. So CH, OCr, OHCl2, OCr, OHCl2, this complex is formed. This on hydrolysis gives you benzaldehyde. So C6H5, CH double bond O is formed and remaining part is given out. Okay. So this is called Itard reaction, very important reaction. Toluene when reacted with chromyl chloride, it gives a chromium complex. Okay. So CH is retained and then remaining OCr, OHCl2, OCr, OHCl2. So H gets added here. There were 3 H, 1 H is retained here, 2 H's are there with the complex. Okay. Then this is given out on hydrolysis and you get benzaldehyde. Okay. Then by oxidation of methyl benzene using chromium oxide. So when methyl benzene is reacted with chromium oxide in the presence of acetic anhydride, then at 273 Kelvin to 283 Kelvin the reaction takes place. A complex is formed CH, OCOCH3, OCOCH3 and this on heating and hydrolysis gives you benzaldehyde. Okay. And the remaining part of the anhydride is given out. Clear? Then chlorination of side chain of benzene, methyl benzene, that is toluene. So toluene on chlorination gives you benzyl chloride. This benzyl chloride on hydrolysis gives you benzyl dihydroxide and with water molecule is given out because two OH groups are attached with one carbon. So water molecule is given out and benzaldehyde is formed. So this takes place in the presence of H plus and when heated to 373 Kelvin. Then Gattermann-Koch formulation of aniline. So when benzene is reacted with carbon monoxide and HCl in the presence of anhydrous aluminum chloride and pressure, benzaldehyde is formed. Okay, benzene, carbon monoxide, HCl, and hydrous aluminum chloride. It gives you high pressure, gives you benzaldehyde. Here, then Friedel-Crafts acylation of arenes. So when you benzene reacted with acetyl chloride in the presence of Lewis acid, aluminum chloride, it forms acetophenone plus HCl. Okay. Then preparation of aldehyde from ester. Ester on reaction with diabyl H gives you aldehyde. Clear? Aldehyde plus alcohol. Now physical properties of aldehydes and ketones. So first is nature of interacting forces. So the carbonyl bond in aldehyde and ketone is a polar covalent bond. Oxygen is electronegative, carbon is electropositive. Oxygen attracts the electron towards itself. The delta plus and delta negative charges are created. So hence these compounds have dipole-dipole force of attraction. So between the molecules there will be dipole-dipole force of attraction. Okay. Then physical state and boiling point of aldehydes and ketones. Formaldehyde is a gas at room temperature having very irritating odor. Acetaldehyde is extremely volatile, colorless liquid. Higher aldehydes have pleasant smell. Then acetone is a liquid at room temperature. It also has a pleasant odor. The nail polish remover is acetone. And higher ketones have a bland odor. Then boiling point of aldehydes and ketone increases with increasing molecular mass because van der Waals forces increase. Solubility of aldehydes and ketones. Now because the molecule of aldehyde and ketone is polar, it is soluble in water because it forms hydrogen bonding with water. Okay. Then solubility decreases with increase in molecular mass because the hydrocarbon part increases and the molecule cannot form hydrogen bonds. Clear? Then polarity of the carbonyl group. Due to the polarity of the carbonyl group, carbon is electron deficient. As a result, carbonyl carbon acts as a new electrophile and it is susceptible to the attack by the nucleophile. Okay. So because of the polarity, the nucleophile can easily attack on the carbonyl carbon and the reaction takes place. Okay. Clear? Thank you.